Hey everyone, this is Andrew, and here's another information for you. Intersection fields are fields that show the equivalence in the scalar values of rays. So for fields, these kinds of different areas of play places, you can find the intersection of two different rays. In order to know about the intersection, of course we must go back to scalar values. So we have a scalar value of 0 because that's the initial point, and then we have x. Just a number, some sort of value. We don't have a concrete value. We can use this as a point. Points, scalar values, they're the same thing. So, when we can do this, this is ray A, and that we know that the scalar value of 0 of A is not equal to the scalar value of 0 of A. This kind of value is different. If they're the same, then they have to be the same point, in which this is true no matter what. The scalar value of 0, it's equal to itself. And when you have two different rays, like this, let's draw 0, 0, and we have I. That stands for intersection. So we have B and C. Now here's a trick. I is a point, and it's also a scalar value. We can do the scalar value of I of B is equal to the scalar value of I of C. No matter what value B has, with the value of I, it's always going to be here, and with the value of I for C, it's going to be at the same location, hence an intersection. So now, how do we represent different kinds of fields for intersections? The cool thing about rays is that you can go all out. There's a different kind of theory for rays. So they can either continue in the same direction, they can also go away, and in some cases, you can go wherever it could be. But rays, in order for them to be going straight, no matter what, we can do another arrow, showing that they're direct, like that. So on how we're going to do this, let's draw a ray that is pointing downwards, like this, two direct rays. This is going to be ray D, and then let's do another one. Yeah, do like this, ray E. And for this, there's definitely going to be an intersection point. But how do we do that in terms of analysis? How do we represent these kinds of rays? So you can start off with if D and E are direct rays, and you have to mention about their points too. We have directions north, south, east, west. And what we can do, we can generalize the direction by doing values in between these directions. And the order doesn't really matter. Whether we're going from east to north or north to east, we've kind of gotten our point already. We've kind of did that. So direction of D is equal to N. Or how would we do this? Let's see. Yeah, N such that we have D, and it's between south and east. So S is less than N is less than E, and the direction of E is equal to M such that south is less than M is less than east. And in that way, now we know about the direction. It's somewhere between these main points, these main types of directions in the X and Y axis. Now, what if we have all of this? We still need one more point, and it's about the position, because we can have the same rays, D and E, like this. Let's say this one's D and this one's E. That's not what we want. There isn't going to be an intersection, because these are going to go forever and not going to touch each other. No value would be in both E and D. We can do a position by doing p, and then as x approaches infinity. Because we need to find some sort of method from left to right is when x approaches infinity, and then x approaches negative infinity is when you go from right to left. For diagonals, it gets a lot more complicated because both x and y are approaching infinity, and it might not even be the case if you want to check from here, kind of like where y equals x, or if you want to do like some sort of slope of 2x. Okay, more about that later. But this is a set where it would be DE. If that all of these criteria are met, if D and E are direct rays and the direction of D is between south and east, and direction of E is between south and east. Hold on, I made a mistake. Direction of E should be west and south. Okay. Now, and if the position is DE, from left to right, there is an intersection where S of I of D equals S sub I of E. And that's pretty much it when it comes to these kinds of theoretically things, these kinds of fields. Now what's special about fields is that they have their own properties, and it's very fun to draw one and to even analyze. And of course, there's more and more things to go on with. So if these two rays are direct, then of course they're going to have an intersection. But how would you talk about their directions? Because this direction, the direction of the ray is different, starting from over here, and then versus as it remains going here forever. It's quite an interesting thing to talk about. And I hope I can talk more about these kinds of fields. Seriously, they are very fun to do. See you later, and thanks for watching.